Hey everyone, and welcome to another episode of CUDA Crash Course. My name is Nick from Coffee Before Arch, and we're going to be doing something a little bit different today. So I had a lot of problems starting out with CUDA development on Windows. I was very much used to a Linux environment. Most of my work that I do in my lab is on a Linux machine, specifically Ubuntu. So, I wasn't really used to using, big fancy IDE like Visual Studio. And I ended up having to do a lot of debugging and solve a lot of problems before I was able to even compile the code that I had. So I wanted to give a quick guide of really how I got things up and running and how I end up setting up my environment. So in this case, let's start with the only two things I'm going to assume are two very basic fundamental requirements, and that is A, you are fully capable of downloading the Community Visual Studio Edition and going through a normal Windows installer, and then B, you're able to do the same thing for the CUDA Toolkit installer. So in order to develop for Visual Studio CUDA applications, you'll have to, of course, first download Visual Studio. The Community Edition is the free version, so that's what I'm using. And then, of course, you'll need the CUDA Toolkit. So you'll just have to have Visual Studio installed first, and then you'll just click, if you're on a Windows environment, which is what this is covering, you'll just click the Windows installer, and you'll just have a nice GUI that you click through. So we're done with assumptions. So how do we begin? So the way that I start every single one of my projects is I'll go to you don't have to worry about this part as much. You could go up here and do new project, but in my case, I'm working off of a Git repository, but that's not required. So over here, I'll just make a new solution, which is the same thing as if I did a new project over there. And so what I'll actually start with is I'll use a empty Visual C++ project, and then I'll just call this VS Setup. And I don't want to create a new Git repository, but I do want a new directory. And then, okay, so it should open up a new project for me and generate some stuff for me. All right, there we go. So here we go. We've got our directory structure. We've got our project, any external dependencies, header files, resource files, and source files. So there's a couple things we need to do starting out. So the first thing we need to do is we need to go to build dependencies. So what dependencies do we need in order to actually build our CUDA project? And we'll need to go to over there, and then you should have, depending on your CUDA version, it may be different. I have CUDA 10 on here, so I'll just click CUDA 10, and then this will automatically add this this path right here. So I'll just press OK, and that's all I need to do for that step. Then there's something else. So if I just jump into creating a source file, there's still some problems where I need to be able to, when I call something like CUDA malloc, or when I call something like, a kernel launch or something, I'll need to be able to find the library that is for the CUDA runtime, right? So I'll need access to that runtime library. So in order to, do that, we'll have to go to properties. It came up over there. And there's a couple things that we should know. So a lot of times people have problems with the default options in Visual Studio. So over here, it will say target machine platform, 32-bit machine. We'll need to actually change this to being a 64-bit machine. This legacy thing seems to be broken, so you can't actually compile for 32-bit, and so we'll need to make sure that we change this. And so go ahead and change that, and then click Apply. And then what else do we need? So we're going to, like I said, we need access to the CUDA runtime library. And so this is going to be the responsibility of the linker. When at compile time, we're going to link the runtime library. So here we have the linker and our input, and with additional dependencies, we're going to need to add the CUDA runtime library. And so the name of the CUDA runtime library is exactly what you think it'd be. It's CUDA rt, so rt for runtime, .lib. And then that's it. So that should be added now as an additional dependency. And then we'll just click apply. All right, so that's going to be most of our setup that we need. So let's go ahead and we'll add a new file, so a new item. This time we go here, we'll go to code, and we'll add a CUDA C++ file. And so here we'll just call it the same name. It doesn't need to be the same name as the project, but we'll use it for kind of consistency. So we'll call it via setup. Okay, so here we are. We have our, just a CUDA basic file with the CUDA extension right now, so it doesn't do anything. So let's go ahead and kind of expand on that. So this program is an example to show the VS setup for CUDA. Okay, and then of course it's going to be by your pal Nick from Coffee Before Arch. Okay. Okay, so what do we need? So the first thing we're going to need, of course, is going to be some includes, right? And includes are what we are going to use to find the individual, or that are going to have the CUDA specific functions in it, and also some of the parameter stuff that we need that is defined for CUDA. So we'll include, we need two specific includes. So one of them is going to be CUDA runtime, which will have all of our functions like CUDA malloc. And then for a lot of the other properties, we're going to need something called device launch parameters. And so that's where we get the rest of the things that we need for any regular CUDA program. So then, of course, we can have a simple CUDA kernel with global, and we can write a CUDA kernel that doesn't do anything. So we can do global void test, right? And just have it do absolutely nothing. So we'll just call this an empty kernel. Okay. So then we'll have a main function, and we can simply just call this CUDA we can just call the simple kernel. So in this case, we'll just use normal notation, everything. So all we need to do is do it'll be test, and then it's that triple kind of chevron notation. Now I'll just launch it with one thread block, and of course one thread per thread block. It doesn't matter what these are because the function itself doesn't do anything. You might run into some formatting issues here because it doesn't seem like IntelliSense, which kind of does this formatting stuff, doesn't really know about CUDA notation. So it really doesn't like these triple less than signs. You'll always end up getting this little red tilde underneath. So don't worry. It happens with a lot of things. It also happens if you do, like in a kernel, if you wanted to say do sync threads. It doesn't seem to be able to find this either. So this will still compile and it will still work. However, you get some annoying red underlines. Okay. So that's going to be our CUDA launch. And then we can just do return 0. So let's see what happens when we try to build. I left something out. I'll let you try to guess what that is. So we'll go ahead and just build. And let's see what happens. So it builds and we get some weird error. So this MSB 3721, right? And so it seems like something's not working. Now, we need to kind of remember something that was going on here. So if we go back to our properties, right? There's something that you need to keep in mind. So take a look at configuration and platform, right? So remember, when we looked at CUDA CC, we changed the target machine platform to be 64-bit. So if we go to debug, which turns out is set up here, you have to make sure that what configuration you're editing when you do properties here matches whatever's up here, right? So it turns out debug for 64-bit is using this 32-bit, this flag that says you're compiling for a 32-bit machine. So we need to make sure that we can do a couple things here. So either A, we could change it for the option up here, or we can just change it to say release and platform as an x64 platform. So that's what we'll do. That's what I normally do. So all I need to do is change this to release. I need to make sure that this isn't x86. I need to make sure that it's x64. And let's see if that solves that. So let's do rebuild. Okay, so there we go. And we get a build successful. So that's the very fundamentals of what you kind of need to know to get up and running with Visual Studio. So we can launch this, and it will do absolutely nothing because it's the kernel is empty. The kernel doesn't do anything. We're launching one thread with one thread block for kernel that has nothing. So it may even optimize out this code. Okay, so like I said, that's going to do it for this example. Let's just kind of recap what we need to do. So we need to make sure that after we install Visual Studio, we install the CUDA SDK. Then we go to build dependencies and build customizations. And we need to make sure that we add whatever CUDA version is right here, this path. So all we need to do is check that box, click OK. Then after that, we go to properties. We need to make sure that whatever configuration that we're changing up here is the same that's matching what we're actually building up here. So first thing we need to do is under the CUDA C++, we change the target machine platform to be 64-bit. Otherwise, we get that weird MSB error. And then we need to make sure that the linker itself, for an input, we need to make sure as an additional dependence, we are adding edit. So we need to make sure we add CUDA-rt.lib. So we're linking against the CUDA runtime. Okay, so that's going to do it there. And then to get all the various CUDA things that we need to launch a normal kernel, we need to of course include things like CUDA runtime.h and device launch parameters.h. So CUDA runtime.h for all of the CUDA runtime.h for things like CUDA malloc, and then device launch parameters.h for things like thread ID X and blocked-in.x. I believe that's what that's for. Okay, so like I said, that's going to do it for this example. That's very basics. Of course, if you're going to use another library like cuDNN or cuBLOS, you'll need to both include, say, cuBLOS, and then also in your libraries that you link against, you'll need to, say, link against cuBLOS.lib or cuDNN.lib. Okay, so let's go ahead and just push this simple example up to, there we go, we'll go changes, and we'll say, we'll push this to GitHub, so it'll be push simple vs setup example. All right, so we'll commit and push, and let's see if it gives, okay, I figured, I changed the README, so I'll need to pull before I push again. And that should update it. Okay, so that's going to do it for today. Of course, you can check out all this code and my, my everything else that I upload on GitHub, my C++ crash course, Python 3, MIPS, and then also some research papers that I go over in another video series. So of course, if we go to repositories and we go to CUDA programming, we can look at this VS setup. VS setup and then VS setup.cu. So this is the example. So not much to look at here, but it's a simple shell that you can look at to build other programs. So I hope this helps with any pains or agony you might be facing with how do I get started with Visual Studio and CUDA. So if you have any questions, feel free to message me. And if you look at this page where we have all the videos and links to the videos, the concepts, and then the files, feel free to look at any of these, download the code, or to get in contact with me. I've got my email, coffeebeforearch@gmail.com, or comment on the video. So like I said, I'm Nick from Coffee Before Arch, and I hope you had a nice day.